And in today's class, we are going to discuss about the common ion effect. What is called common ion effect? The common ion effect is nothing but when the addition of weaker acids salt to the acid, the dissociation of weaker acid is further suppressed. The weaker acid is already poorly dissociated, partially dissociated. Always the weaker acids are partially dissociated. To the weaker acid, we should select a salt of its own. Its own salt is added means the dissociation of weaker acid is further decreased. That is nothing but suppression. The decrease in the dissociation of weaker acid by the addition of its own salt, it can be called as common ion effect. Consider the following acid, CH3COOH. It is nothing but acetic acid that is partially dissociated to form acetate ion and H plus ion. It's not completely ionized and hence it is a weaker electrolyte. And to that, we are adding a stronger electrolyte, CH3COONA, sodium acetate. The salt of the same acid is added. When you take this salt, it's a stronger electrolyte and that would be completely dissociated to form CH3COO minus and Na plus. Now you see, the concentration of acetate increases. This ion is becoming common ion. And you know what is called the Le Chatelier principle? According to the Le Chatelier principle, whenever any constraint or disturbance is placed on a system at equilibrium, the system will adjust itself to nullify the effect of constraint. We are trying to increase the concentration of acetate by the addition of sodium acetate, but equilibrium is managing itself to become backward action and it is shifted backward direction or shifted into backward, which means we can have more and more undissociated acetic acid. The dissociation of acetic acid is very poor. On the addition of its sodium salt, we are getting the common ion. This acetate ion is becoming common. It is disturbing the equilibrium and shifting the direction of equilibrium in the backward direction so that we can have more and more number of unionized acetic acid. This effect is said to be common ion effect. It is not only the example, but we can take some other examples, weaker base and its salt. Just for example, ammonium hydroxide and ammonium chloride. Okay. Another example for common ion effect. And we know that the common ion effect, the dissociation of weak acid, otherwise weak base, is further suppressed, which means it is lowered, decreased by the addition of salt of its own acid. When you take a weaker base, we should add the salt of that particular base. Previously we were seeing the acid and its salt. At present we have to learn about weaker base and its own salt. The best example of weaker base is ammonium hydroxide, NH4OH. It gets partially dissociated to form NH4 plus and OH minus. It's a weaker electrolyte and it gets partially dissociated. To that, we are going to supply the ammonium chloride, NH4Cl. It is a stronger electrolyte. ammonium chloride. It is a stronger electrolyte that gets completely ionized to form NH4 plus and Cl minus ion. Now, the ammonium is becoming common. So, the concentration of ammonium ion increases, which means we are disturbing the equilibrium. Based on the Le-Chatelier principle, we know that when any constraint or disturbance is placed on a system at equilibrium, the system will adjust itself to nullify the effect of constraint. We are trying to increase the concentration of NH4 plus, and equilibrium is adjusting itself to become backward type action or backward reaction or backward direction in which the equilibrium is shifted, so that we can have plenty of undissociated or unionized ammonium hydroxide. Already the dissociation of ammonium hydroxide is poor. By the addition of its salt, the common ion increases. So it disturbs the equilibrium, and the equilibrium is proceeding in backward direction, and according to the Le-Chatelier principle, so that we can have undissociated ammonium hydroxide. So it clearly shows that the dissociation of weak base is further suppressed by the addition of salt of its own base, otherwise salt of its own. The salt is ammonium chloride and the base is ammonium hydroxide. So this is about the common ion effect. Is it clear? Okay.